So we got the solution here that for n equal to n prime, what we will get? This will become a over 2 for n equal to n prime. For n equals n prime, this thing is equal to a over 2 cn times a over 2. So when that a over 2 will come here, it will become 2 over a, and we get that cn is equal to 2 over a and integral from 0 to a and v naught of y and sine as n is equal to n prime. So we will write this n pi y over a and dy. So if we find this thing, the value of v naught y, if this is with us, then we can find the value of cn here. Now this thing, we can find that what is the value of v naught y. This is basically v naught, means the potential is v naught. So I can write that cn is equal to 2 times v naught over a and sine of integral from 0 to a and sine of n pi y over a and dy. Now we will have to solve this integral, and the solution of this integral I am writing directly that this is equal to 2v naught or 2v naught from here and a 2v naught over a is here. But look here, when I'm writing this thing in the form of this, means the integral sign, it will be in the form of cos. So n pi and a will be simplified, and this is 2v naught. When a here, this will be divided by n pi over a, so n pi over a, and it will become a over n pi. So a will be cancelled and we will have only the n pi here, and 1 for this one it will become cos. So when cos is at the value 0, it will be equal to 1, and when it will be at a value a, then it will be cos n phi. When y will be equal to, first means the integral is easy, it is not that difficult. It will become sine, so it will become cos of it and divided by n pi over a, so it will be simplified. A will cancel and n pi comes in here, and we have the other value. When cos of 0 will become 1 when we put the limit, and minus it will be sine, so it will be cos of n pi, and when y will be equal to a, then a will cancel, so we will have cos of n pi, and this thing is equal, this is equal, that it depends now on the value of n. If n will be even, then what will happen, and when n will be odd, what will happen? Because we know that n is an integer, and earlier we have derived for n that it is equal to 1, 2, 3. Now if it will be even, like 2, 4 and so on, so cos 2 pi is equal to 1, cos 4 pi is equal to 1. But when this is 1 minus 1, so it will become 0. So for all values of n, if this is equal to, if n is even, then this thing will be 1 minus 1, so it will be 0, and we will get 2v naught over n phi and multiplied by 0, and this is equal to 0 if n is even. And what if n is odd, like 1, 3, 5, and so on? Then cos phi is equal to minus 1. Minus 1 and minus 1 become plus 1. 1 plus 1 becomes 2, so it will become equal to 4 times v naught over n pi. So 4 times v naught over n pi if n is odd. So we got our solution is equal to v of xy equals 4v naught over, because the n we will have to move into the summation, so I am writing 4v naught over n, 4v naught over pi, and then summation on summation. Now the summation on n will be only on odd numbers, because the even, for the even we have calculated the value and it is equal to this, and 1 over n e to the power minus n pi x over a, and sine of n pi y over a. This is our solution so far. Now in another segment I will explain, or I will plot this thing, and will discuss the plot of it, that how it x equal to how it, now this is the solution, how it x equal to 0, this solution, this v of xy goes to v naught, because this was our third boundary condition, the important one behind which we are going. So I will explain in that segment that how this thing is equal to 8x0, this thing comes out to be equal to v naught. We can write this solution in another form in order to do a little bit of trick with this one. So this is this can be written in this form as well, that if I write 2 over n, this solution can also be written in this form. Now how to do this thing, you can do a practice on this thing. Let me give you some hint for converting it, because here if I look here, then this one is in the form of exponential, while this one in the form of sine, and we know about the exponential form, that we can write this thing in terms of the hyperbolic function of sine, because we know that from the Euler formula, we know that sine of x can be written in the form of eix plus e minus ix divided by 2. Similarly, cos can also be written in the form of e to the power x plus e to the power minus x. When you will write this in that form, then sine hyperbolic x will be introduced, and on further simplification you can write this thing, that this will finally come out to be 2v naught over a, and tangent inverse sine phi y over a, sine phi y over a, and divide by sine phi sine hyperbolic phi x over A. The one that I told you, that the sine component is, there is no iota involvement here, so it will convert into sine hyperbolic here with us, and after simplification we will get this thing in terms of tangent inverse. So this is the way that we solved our geometry, and we solved this thing. We found the potential, that how this potential is varying in between the two plates here. Look here to the solution again a little. This is exponentially decaying solution, means the potential is basically decaying here, one thing, and another, it is sinusoidally varying. So it is in the form of this, and it will generate some polynomials here, and I will discuss this and will plot this solution, and we will come to know that how the solution is varying, how the potential is varying between these two plates. If there are no ground plates here, then the potential is supposed to be just going is 1 over r here from the plate onward, and the existence are putting the plates here, the grounded plates here will change the behavior of this potential. So I hope that we have discussed this in more details, this example 3.3, and onward we will start with example 3.4. Now, in order to discuss the solution, we are having v of xy, which is 4v naught, and summation on odd numbers 1, 3, 5 and so on, 1 over n and e to the power minus n pi x over a and sine n pi y over a. Now this portion, which is dependent on the x, if I remove this one and only leave the y portion, then to plot the response of this function, I have designed a couple of Python codes, very small codes, one for the 2D plots and the other for the 3D plots. So let me discuss the code here. I will have to import the library first, the NumPy, and then another library of the matplot. Then I will have to define my potential, and what I have done, I have written basically the equation, which is only the y dependent one, which is here, that v of y is only this portion. So I will plot the v of y with y over a. I will normalize this one, v over v naught, and then it will be plotted with y over a. So here let's discuss the code here. That this is basically that equation that I have, and I am running a loop on this one in order to have the different y over a values, and here I will have to put the number of terms here. So when the number of term is 1, then we are having the plot between v over v naught, normalized potential, and then y over a, the normalized y as well with respect to a, and rest is just a loop for the n terms here, and then some plot specifications here, that what kind of plot it will be. And for the first term we are having the plot like this. When the number of terms equal to 1, we are having the plot of v over v naught and y over a like this one. Now let me change here the number of terms, and let's say now the next term which will come here will be the third term, like only odd numbers are here, so third term will come here, and let me run this one, and you see here that n equal to 3, then we are having the plot like this one. We are having 2 peaks involved here. Similarly, if I increase the number of terms to the third term, like it will be the fifth term here, the odd one. The total number of terms are 3, 1, 3, 5. So I run this one and I see that now the green one comes with n equal to 5 and the number of peaks are increasing. These two peaks are having height more than this one, and we will go to means V over V naught will be reaching one value, like the potential will become normalized, V will become equal to V naught. So here this is the, let's say I go to 7 terms here and I run this and I can see that this is now just focusing on this one, and as in the book they are going up to 100 of terms, almost constant. So let me write few terms here more, and this is 15, and now I can see that it has gone. You see this one, that it is now just becoming constant on this value, means going close to that one. And if I add more terms like 17, then 19, then 21, and so 23, 25, and 27, for example, and I run this, and now I can see this thing that it is becoming more straight line here. Now let's say I just means I have plotted all those number individually, and now as the book is reaching almost 100 terms, let's say I reach 101, and then we can see that it has almost become constant here, while for terms like, let's say 1001, it has almost become constant. So it has reached V or V naught and it is almost constant. So the more the number of terms, more will be the accuracy, and we will reach to the constant value, means our potential will reach V naught. Similarly, in the same sense, when we are plotting the next equation, means the equation for the 3D, then it is here when both x over a and y over a are plotted on two axes and v of xy is plotted on the third axis, then we will have the results like this. Means the same thing, I am just importing a couple of libraries and then the 3D plot here as well. I am writing the complete equation here in Python, and now here the number of terms, and then rest of the code basically generating a mesh grid and all this. When the number of term is just 1, then I can see that the plot is like this. I am extra generating is 3D plot need to be visualized from different angles. So I'm just, you can say, producing different orientations with the help of the code. And here it is. This is one orientation, another, and another. In 3 different orientations, I am going to see it. Here I can see this is x over a on this axis from 0 to 1, and y over a from 0 to 1, and similarly the v over v naught here. Now there is one difference that I have made with respect to the book, because on the x-axis it is from 0 to 2, while the y-axis is 0 to 1. So that only elongates this figure, but I am not elongating the plot. I just want to have the same axes for x and y, and here I can see that there is only, as like previous, only one peak is involved. Now let's say I change the number of terms, mean after 1 we are having 3, and 3 means that 2 terms will be involved there, and you see that in three-dimensional I can see that the number of peaks has increased to 2, and it is a curve like this, while in the book we are having the same thing, okay, but there is only one orientation. Now let's say I change the number of terms to 5, and see here that the number of peaks will increase, and they are now 3 here. Similarly, changing the number of, as we increase the number of peaks to 7, then we will see that the number of peaks will increase as well, and here it is. If I do increase this one, the number of terms, let's say to 17, then here I will see that the number of peak will increase, and we are going closer and closer to the 1 value, which is basically the v is reaching the constant value v0. And for terms like as I did earlier, let's say 107 terms, then we are having almost constant here, as now the contribution is from 2 axes, so it is becoming constant at slightly lower values, lower number of terms compared to the two-dimensional plot. And this way, as we increase the number of terms, the value is reaching, v is reaching v0, and v over v0 will reach the 1 value.